This is a video on solving systems of linear equations by substitution. When you're given a system of linear equations, you're going to be given two equations and you're going to try to find the point where these two lines cross is really what we're looking for here. So this is going to give us an algebraic way of finding that. Your first step, is to pick one of the equations and isolate one of the variables on one side of it. And generally speaking, if you can isolate a variable that has a coefficient of 1, that's the variable you should isolate. Mainly because it's easier to solve that one. Once you have that, you want to substitute that variable into the other equation, the equation that you didn't use in step 1, and then this will create an equation with only a single variable remaining in it. So you're substituting into the other equation. Once you have that, since you have an equation with a single variable, you're going to solve for that variable. That's what step 3 says here. Solve the equation in step 2 for the remaining variable. Step 4, take that variable that you just found and back substitute it into the original equation, to find the other coordinate. Because remember, this is a point where they're going to cross, so you need an x and a y value. So you're going to find one of them in step 3. To get the other coordinate, you'll go back in step 4 and substitute into the original equation. In step 5, you should do this on your own to make sure you're correct, is check your answer in both equations. If you check it in just one equation, it doesn't necessarily tell you it's the answer, it just tells you that it's on that first line. To check it in both equations tells you that it's the point where they cross. So let's take a look at an example here. So we want to solve the equation by substitute, or solve the system by substitution. We got 6x plus 3y equals 24. I'll call that equation 1. And x minus 5y equals negative 18. I'll call that equation 2. And to solve by substitution, our first step, we said, was to isolate a single variable in one of the equations. And I'm going to pick to isolate x in equation 2 here because it doesn't have a coefficient other than 1. In other words, all these other variables have a number in front of them. X, you don't see a number in front of it, so the coefficient is 1 there. It's the easiest variable to isolate. So we're going to isolate x in equation 2 here on one side. So we're going to have x minus 5y equals negative 18. And to isolate x, I have to add 5y to both sides. I'm going to add 5y. I'm going to add 5y. So I get x equals 5y minus 18. Now once I have that, my step 2 says I have to substitute this into the other equation. So remember, we started with equation 2 here. I'm going to substitute this into equation 1 for x. I'm going to replace x with x is equal to 5y minus 18. So in equation 1, I'm going to put 5y minus 18 right where I see x. So this equation 1, so we're going to sub into equation 1. So you're going to have 6 times 5y minus 18. Now just replacing x with 5y minus 18. Make sure you have parentheses there. Plus 3y equals 24. And now you solve this like you normally would. Notice we only have one variable remaining. There's only y's. So we're going to distribute through. So 6 times 5y gives us 30y. 6 times a negative 18 gives us a minus 108. Plus 3y equals 24. 30y plus 3y gives us 33y minus 108 equals 24. And if we add 108 to both sides here, this will give us 33y is equal to 132. Solving for y, we're going to divide by 33. Divide by 33. And this gives us y equals 132 divided by 33 is 4. Now you can't stop here. Once you have y equals 4, remember we're looking for the point where these two lines cross. So we need to find the x value that goes with it. The way we do this is by substituting into one of the original equations. It doesn't matter which one. I'll sub into equation 2. So that was x minus 5y equals negative 18. And I'm going to sub in y equals 4. So we're going to have x minus 5 times 4 equals negative 18. So this is x minus 20 equals negative 18. We're going to add 20 to both sides. Add 20, solving for x, we get x equals 2. So our coordinate, our actual solution to this whole thing is going to be the point x comma y is 2 comma 4. Now you could check this in both equations on your own to verify its solution, but remember it has to work in both. So our answer would be 2 comma 4 for that system. Here's a system for you to try to solve on your own.